All right, in this question we are trying to construct a 99% confidence interval for the true proportion of mean textbook weights. We measured a sample of 30 and we found that the sample mean here was, that sample had a mean of 78, and we know that the population standard deviation is 2.6, or 2.3, so we know that sigma is equal to 2.3. Our x bar is 78 and our sample size is 30, and we're trying to construct a 99% confidence interval for the true mean proportion of these textbooks. And we've got a sufficiently large sample that our sampling distribution should probably be a normal distribution. And what we're trying to find is how far out do we have to go on that normal distribution to capture 99% of the values. And so we're trying to find what's the z star or the negative z star. You know, how far from the center do you have to go out on that standard normal distribution to capture 99%? And the easy way to do that is to use the table. There's a table of values in the back of the textbook. It looks something like this. And we're looking at a confidence level of, 99% here. So I want to go from the 99% column all the way down to the bottom. It's table C in the textbook. I want to go all the way down to the bottom, and we get our, it was there. Where did it go? 99% column is this middle column here. And it's 2.576. Do we see it down here? The Z star, 2.576. That one is in the 99% column all the way at the back. It's a little harder to follow along maybe here, but I'm in the 99% column. And if we just follow that column all the way down to the Z star, we see it's 2.576. That's the easy way to find the critical value, is that Z star is 2.576. If we want to do it with our calculator, what I need to do is I need to do an inverse norm, but the inverse norm looks at the entire area to the left. So if I'm like trying to find this spot, I need the area that's completely all the way to the left, and that includes this little chunk that's out here, this tail, this bottom tail. And so I need to do inverse norm of a percentage of a decimal, and it's going to be, I've got 99% is trapped here in the middle between Z star and negative Z star. That means I've got 1% unaccounted for, and because the normal distribution is nice and symmetric, I know that 1% is split up evenly, that there's going to be 0.5% up here on this top area, and this bottom area is also going to be 0.5%, 0.5%. So the total area, everything to the left of this Z star, is going to be the 99% plus the 5% in this bottom tail, this 99% plus the 5% in that bottom tail. So I have to do inverse norm of 0.995. And if you do that on your calculator, you will find second distribution, inverse norm, there's inverse norm of 0.995. And if it's giving you the option, if you're in a thing where it requires the mean and standard deviation, put in the mean. The mu is 0 and the standard deviation is 1. If you're in that situation, that's the standard normal distribution. We'll get our z-score here of 2.5758, which would round to the same decimal points, 2.576. So that's going to be our z-star is, we should get 2.5758 something something something. It rounds to 2.5756 if we or 2.576, the same if we go to the same accuracy that the table does. Okay, and so then we can make our estimate. Our best guess for mu would be that it's 70. What was our sample mean again? 78. and then I want to go 2.576 standard deviations on either side of that mean, multiply it by 2.3 over the square root of 30, because when you're looking at the distribution of sample means, they're going to be, the standard deviation would be 2.3 over the square root of your sample size. And so that will give you your, do the calculation, find out what that margin of error number is, but that will give you the value, the confidence interval.